Monsoon winds of the Arabian Sea. The monsoon winds originating over the Arabian Sea further split into three branches. 1. Its one branch is obstructed by the Western Ghats. These winds climb the slopes of the Western Ghats from 9,001,200 meters. Soon, they become cool, and as a result, the windward side of the Sayadras and western coastal plain receive very heavy rainfall ranging between 250 centimeters and 400 centimeters. After crossing the Western Ghats, these winds descend and get heated up. This reduces humidity in the winds. As a result, these winds cause little rainfall east of the Western Ghats. This region of low rainfall is known as the rainshadow area. Find out the rainfall at Kozhikode, Mangalore, Pune and Bangalore and note the difference, figure 4.10. 2. Another branch of the Arabian Sea monsoon strikes the coast north of Mumbai. Moving along the Narmada and Tapi river valleys, these winds cause rainfall in extensive areas of central India. The Chotanagpur Plateau gets 15 centimeters rainfall from this part of the branch. Thereafter, they enter the Ganga Plains and mingle with the Bay of Bengal branch. 3. A third branch of this monsoon wind strikes the Saurashtra Peninsula and the Kachich. It then passes over West Rajasthan and along the Aravallis, causing only a scanty rainfall. In Punjab and Haryana, it too joins the Bay of Bengal branch. These two branches, reinforced by each other, cause rains in the western Himalayas. Monsoon winds of the Bay of Bengal. The Bay of Bengal branch strikes the coast of Myanmar and part of southeast Bangladesh. But the Arakan hills along the coast of Myanmar deflect a big portion of this branch towards the Indian subcontinent. The monsoon, therefore, enters West Bengal and Bangladesh from south and southeast instead of from the southwesterly direction. From here, this branch splits into two under the influence of the Himalayas, and the thermal low is northwest India. Its one branch moves westward along the Ganga Plains reaching as far as the Punjab Plains. The other branch moves up the Brahmaputra Valley in the north and the northeast, causing widespread rains. Its subbranch strikes the Garo and Khasi hills of Meghalaya. Mawsynram, located on the crest of Khasi Hills, receives the highest average annual rainfall in the world. Here it is important to know why the Tamil Nadu coast remains dry during this season. There are two factors responsible for it. 1. The Tamil Nadu coast is situated parallel to the Bay of Bengal branch of southwest monsoon. 2. It lies in the rain shadow area of the Arabian Sea branch of the southwest monsoon. Characteristics of monsoonal rainfall. 1. Rainfall received from the southwest monsoons is seasonal in character, which occurs between June and September. 2. Monsoonal rainfall is largely governed by relief or topography. For instance, the windward side of the Western Ghats register a rainfall of over 250 centimeters. Again, the heavy rainfall in the northeastern states can be attributed to their hill ranges in the eastern Himalayas. 3. The monsoon rainfall has a declining trend with increasing distance from the sea. Kolkata receives 119 centimeters during the southwest monsoon period, Patna 105 centimeters, Allahabad 76 centimeters and Delhi 56 centimeters. 4. The monsoon rains occur in wet spells of few days' duration at a time. The wet spells are interspersed with rainless interval known as breaks. These breaks in rainfall are related to the cyclonic depressions mainly formed at the head of the Bay of Bengal, and their crossing into the mainland. Besides the frequency and intensity of these depressions, the passage followed by them determines the spatial distribution of rainfall. 5. The summer rainfall comes in a heavy downpour leading to considerable runoff and soil erosion. 6. Monsoons play a pivotal role in the agrarian economy of India because over 3/4 of the total rain in the country is received during the southwest monsoon season. 7. Its spatial distribution is also uneven, which ranges from 12 centimeters to more than 250 centimeters. 8. The beginning of the rains sometimes is considerably delayed over the whole or a part of the country. 9. The rains sometimes end considerably earlier than usual, causing great damage to standing crops and making the sowing of winter crops difficult. Season of retreating monsoon. The months of October and November are known for retreating monsoons. By the end of September, the southwest monsoon becomes weak as the low-pressure trough of the Ganga Plain starts moving southward in response to the southward march of the sun. The monsoon retreats from the western Rajasthan by the first week of September. It withdraws from Rajasthan, Gujarat, western Ganga Plain and the central highlands by the end of the month. By the beginning of October, the low pressure covers northern parts of the Bay of Bengal, and by early November, it moves over Karnataka and Tamil Nadu. By the middle of December, the center of low pressure is completely removed from the peninsula. The retreating southwest monsoon season is marked by clear skies and rise in temperature. The land is still moist. Owing to the conditions of high temperature and humidity, the weather becomes rather oppressive. This is commonly known as the October heat. In the second half of October, the mercury begins to fall rapidly, particularly in northern India. The weather in the retreating monsoon is dry in North India, but it is associated with rain in the eastern part of the peninsula. Here, October and November are the rainiest months of the year. The widespread rain in this season is associated with the passage of cyclonic depressions which originate over the Andaman Sea and manage to cross the eastern coast of the southern peninsula. These tropical cyclones are very destructive. The thickly populated deltas of the Godavari, Krishna and Kaveri are their preferred targets. Every year cyclones bring disaster here. A few cyclonic storms also strike the coast of West Bengal, Bangladesh and Myanmar. A bulk of the rainfall of the Coromandel coast is derived from these depressions and cyclones. Such cyclonic storms are less frequent in the Arabian Sea. Traditional Indian seasons. In the Indian tradition, a year is divided into 6 two-monthly seasons. This cycle of seasons, which the common people in north and central India follow, is based on their practical experience and a geold perception of weather phenomena. However, this system does not match with the seasons of South India, where there is little variation in the seasons. Seasons and months according to Indian calendar and corresponding Georgian calendar. Basanta Kshetra and Vaisakha, March and April. Grishma, Jyesta and Asada, May and June. Varsha, Sravana and Bhadra, July and August. Sharada, Asvina and Kartika, September and October. Hemanta, Margashirsa and Pausa, November and December. Shishira, Maja and Falguna, January and February. Distribution of rainfall. The average annual rainfall in India is about 125 centimeters, but it has great spatial variations. Areas of high rainfall. The highest rainfall occurs along the west coast, on the western Ghats, as well as in the sub-Himalayan areas as the northeast and the hills of Meghalaya. Here the rainfall exceeds 200 centimeters. In some parts of Khasi and Jaintia hills, the rainfall exceeds 1,000 centimeters. In the Brahmaputra Valley and the adjoining hills, the rainfall is less than 200 centimeters. Areas of medium rainfall. Rainfall between 100,000 200 centimeters is received in the southern parts of Gujarat, East Tamil Nadu, northeastern peninsula covering Orissa, Jharkhand, Bihar, eastern Madhya Pradesh, northern Ganga Plain along the sub-Himalayas and the Kashar Valley in Manipur. Areas of low rainfall: Western Uttar Pradesh, Delhi, Haryana, Punjab, Jammu and Kashmir, Eastern Rajasthan, Gujarat and Deccan Plateau receive rainfall between 50,100 centimeters. Areas of inadequate rainfall: parts of the peninsula, especially in Andhra Pradesh, Karnataka and Maharashtra, Ladakh and most of western Rajasthan receive rainfall below 50 centimeters. Snowfall is restricted to the Himalayan region. Variability of rainfall. A characteristic feature of rainfall in India is its variability. The variability of rainfall is computed with the help of the following formula. CV equals standard deviation divided by mean into 100, where CV is the coefficient of variation. The values of coefficient of variation show the change from the mean values of rainfall. The actual rainfall in some places deviates from 20–50%. The values of coefficient of variation show variability of rainfall in India. A variability of less than 25% exists on the western coasts, Western Ghats, northeastern Peninsula, eastern plains of the Ganga, northeastern India, Uttaranchal and Himachal Pradesh and southwestern part of Jammu and Kashmir. These areas have an annual rainfall of over 100 centimeters. A variability of over 50% exists in the western part of Rajasthan, northern part of Jammu and Kashmir and interior parts of the Deccan Plateau. These areas have an annual rainfall of less than 50 centimeters. Rest of India have a variability of 2,550% and these areas receive an annual rainfall between 50,100 centimeters. Figure 4.12. Climatic regions of India. The whole of India has a monsoon type of climate. But the combination of elements of the weather, however, reveal many regional variations. These variations represent the subtypes of the monsoon climate. It is on this basis that the climatic regions can be identified. A climatic region has a homogeneous climatic condition which is the result of a combination of factors. Temperature and rainfall are two important elements which are considered to be decisive in all the schemes of climatic classification. The classification of climate, however, is a complex exercise. There are different schemes of classification of climate. Major climatic types of India based on Köppen's scheme have been described below. Köppen based his scheme of climatic classification on monthly values of temperature and precipitation. He identified 5 major climatic types, namely 1. Tropical climates, where mean monthly temperature throughout the year is over 18 degrees Celsius. 2. Dry climates, where precipitation is very low in comparison to temperature, and hence, dry. If dryness is less, it is semi-arid, S. If it is more, the climate is arid, W. 3. Warm temperate climates, where mean temperature of the coldest month is between 18 degrees Celsius and -3 degrees Celsius. 4. Cool temperate climates, where mean temperature of the warmest month is over 10 degrees Celsius, and mean temperature of the coldest month is under -3 degrees Celsius. 5. Ice climates, where mean temperature of the warmest month is under 10 degrees Celsius. Köppen used letter symbols to denote climatic types as given above. Each type is further subdivided into subtypes on the basis of seasonal variations in the distributional pattern of rainfall and temperature. He used S for semi-arid and W for arid and the following small letters to define subtypes: F, sufficient precipitation; M, rainforest despite a dry monsoon season; W, dry season in winter; H, dry and hot; C, less than 4 months with mean temperature over 10 degrees Celsius; and G, Gangetic plain. Accordingly, India can be divided into 8 climatic regions. Monsoons and the economic life in India. 1. Monsoon is that axis around which revolves the entire agricultural cycle of India. It is because about 64 People of India depend on agriculture for their livelihood, and agriculture itself is based on southwest monsoon. 2. Except Himalayas, all the parts of the country have temperature above the threshold level to grow the crops or plants throughout the year. 3. Regional variations in monsoon climate help in growing various types of crops. 4. Variability of rainfall brings droughts or floods every year in some parts of the country. 5. Agricultural prosperity of India depends very much on timely and adequately distributed rainfall. If it fails, agriculture is adversely affected, particularly in those regions where means of irrigation are not developed. 6. Sudden monsoon burst creates problem of soil erosion over large areas in India. 7. Winter rainfall by temperate cyclones in North India is highly beneficial for rabi crops. 8. Regional climatic variation in India is reflected in the vast variety of food, clothes and house types. Global warming. You know that change is the law of nature. Climate has also witnessed change in the past at the global as well as at local levels. It is changing even now, but the change is imperceptible. A number of geological evidences suggest that once upon a time, large part of the Earth was under ice cover. Now you might have read or heard the debate on global warming. Besides the natural causes, human activities such as large-scale industrialization and presence of polluting gas in the atmosphere are also important factors responsible for global warming. You might have heard about the greenhouse effect while discussing global warming. The temperature of the world is significantly increasing. Carbon dioxide produced by human activities is a major source of concern. This gas, released to the atmosphere in large quantities by burning of fossil fuel, is increasing gradually. Other gases like methane, chlorofluorocarbons, and nitrous oxide, which are present in much smaller concentrations in the atmosphere, together with carbon dioxide, are known as greenhouse gases. These gases are better absorbers of long-wave radiations than carbon. The mean annual surface temperature of the Earth dioxide, and so, are more effective at enhancing the greenhouse effect. These gases have been contributing to global warming. It is said that due to global warming the polar ice caps and mountain glaciers would melt and the amount of water in the oceans would increase. The mean annual surface temperature of the Earth in the past 150 years has increased. It is projected that by the year 2100, global temperature will increase by about 2 degrees Celsius. This rise in temperature will cause many other changes. One of these is a rise in sea level, as a result of melting of glaciers and sea ice due to warming. According to the current prediction, on an average, the sea level will rise 48 centimeters by the end of 21st century. This would increase the incidence of annual flooding. Climatic change would promote insect-borne diseases like malaria, and lead to shift in climatic boundaries, making some regions wetter and others drier. Agricultural pattern would shift and human population as well as the ecosystem would experience change. What would happen to the Indian sea coasts if the sea level rises 50 centimeters above the present one? Difference between weather and climate. Weather is the momentary state of the atmosphere, while climate refers to the average of the weather conditions over a longer period of time. Weather changes quickly, maybe within a day or week, but climate changes imperceptibly and may be noted after 50 years or even more. What is ITCZ? Intertropical Convergence Zone, ITCZ. The Intertropical Convergence Zone, ITCZ, is a low-pressure zone located at the equator where trade winds converge, and so, it is a zone where air tends to ascend. In July, the ITCZ is located around 20 degrees north 25 degrees north latitudes, over the Gangetic Plain, sometimes called the monsoon trough. This monsoon trough encourages the development of thermal low over North and Northwest India. Due to the shift of ITCZ, the trade winds of the southern hemisphere cross the equator between 40 degrees and 60 degrees east longitudes and start blowing from southwest to northeast due to the Coriolis force. It becomes southwest monsoon. In winter, the ITCZ moves southward, and so the reversal of winds from northeast to south and southwest takes place. They are called northeast monsoons. El Niño and the Indian monsoon. El Niño is a complex weather system that appears once every 3 to 7 years, bringing drought, floods and other weather extremes to different parts of the world. The system involves oceanic and atmospheric phenomena with the appearance of warm currents off the coast of Peru in the eastern Pacific and affects weather in many places including India. El Niño is merely an extension of the warm equatorial current which gets replaced temporarily by cold Peruvian current or Humboldt current. Locate these currents in your atlas. This current increases the temperature of water on the Peruvian coast by 10 degrees Celsius. This results in 1. The distortion of equatorial atmospheric circulation. 2. Irregularities in the evaporation of seawater. 3. Reduction in the amount of planktons which further reduces the number of fish in the sea. The word El Niño means child Christ because this current appears around Christmas in December. December is a summer month in Peru, southern hemisphere. El Niño is used in India for forecasting long-range monsoon rainfall. In 199,091, there was a wild El Niño event and the onset of southwest monsoon was delayed over most parts of the country ranging from 5 to 12 days. Understanding the monsoon. Attempts have been made to understand the nature and mechanism of the monsoon on the basis of data collected on land, oceans and in the upper atmosphere. The intensity of southwest monsoon winds of southern oscillation can be measured, among others, by measuring the difference in pressure between Tahiti, roughly 20 degrees south and 140 degrees west, in French Polynesia and East Pacific and Port Darwin, 12 degrees 30s and 131 degrees east, in northern Australia. Indian Meteorological Department, IMD, can forecast the possible behavior of monsoons on the basis of 16 indicators. Chapter 5. Natural vegetation. Have you ever been to a forest for a picnic? You might have surely gone to a park if you live in a city or to a mango, guava or coconut orchard, if you live in a village. How do you differentiate between the natural vegetation and the planted vegetation? The same variety may be found growing wild in the forest under natural conditions and the same tree may be the planted one in your garden under human supervision. Natural vegetation refers to a plant community that has been left undisturbed over a long time, so as to allow its individual species to adjust themselves to climate and soil conditions as fully as possible. India is a land of great variety of natural vegetation. Himalayan heights are marked with temperate vegetation, the Western Ghats and the Andaman-Nicobar Islands have tropical rainforests, the deltaic regions have tropical forests and mangroves, the desert and semi-desert areas of Rajasthan are known for cacti, a wide variety of bushes and thorny vegetation. Depending upon the variations in the climate and the soil, the vegetation of India changes from one region to another. On the basis of certain common features such as predominant vegetation type and climatic regions, Indian forests can be divided into the following groups. Types of forests. 1. Tropical evergreen and semi-evergreen forests. 2. Tropical deciduous forests. 3. Tropical thorn forests. 4. Montane forests. 5. Littoral and swamp forests. Tropical evergreen and semi-evergreen forests. These forests are found in the western slope of the Western Ghats, hills of the northeastern region and the Andaman and Nicobar Islands. They are found in warm and humid areas with an annual precipitation of over 200 centimeters and mean annual temperature above 22 degrees Celsius. Tropical evergreen forests are well stratified, with layers closer to the ground and are covered with shrubs and creepers, with short structured trees followed by tall variety of trees. In these forests, trees reach great heights up to 60 meters or above. There is no definite time for trees to shed their leaves, flowering and fruition. As such, these forests appear green all the year round. Species found in these forests include rosewood, mahogany, any, ebony, etc. The semi-evergreen forests are found in the less rainy parts of these regions. Such forests have a mixture of evergreen and moist deciduous trees. The undergrowing climbers provide an evergreen character to these forests. Main species are white cedar, hollock and kyle. The British were aware of the economic value of the forests in India, hence, large-scale exploitation of these forests was started. The structure of forests was also changed. The oak forests in Garhwal and Kumaon were replaced by pine, firs, which was needed to lay railway lines. Forests were also cleared for introducing plantations of tea, rubber and coffee. The British also used timber for construction activities as it acts as an insulator of heat. The protectional use of forests was, thus, replaced by commercial use. Tropical deciduous forests. These are the most widespread forests in India. They are also called the monsoon forests. They spread over regions which receive rainfall between 70,200 centimeters. On the basis of the availability of water, these forests are further divided into moist and dry deciduous. The moist deciduous forests are more pronounced in the regions which record rainfall between 100,200 centimeters. These forests are found in the northeastern states along the foothills of Himalayas, eastern slopes of the western Ghats and Orissa. Teak, sal, shisham, hora, mahua, amla, semul, kusum, and sandalwood etc. are the main species of these forests. Dry deciduous forest covers vast areas of the country, where rainfall ranges between 70,100 centimeters. On the wetter margins, it has a transition to the moist deciduous, while on the drier margins to thorn forests. These forests are found in rainier areas of the peninsula and the plains of Uttar Pradesh and Bihar. In the higher rainfall regions of the peninsular plateau and the northern Indian plain, these forests have a parkland landscape with open stret chess in which teak and other trees interspersed with patches of grass are common. As the dry season begins, the trees shed their leaves completely and the forest appears like a vast grassland with naked trees all around. Tandu, palas, amaltas, bel, care, axlewood, etc. are the common trees of these forests. In the western and southern part of Rajasthan, vegetation cover is very scanty due to low rainfall and overgrazing. Tropical thorn forests. Tropical thorn forests occur in the areas which receive rainfall less than 50 centimeters. These consist of a variety of grasses and shrubs. It includes semi-arid areas of southwest Punjab, Haryana, Rajasthan, Gujarat, Madhya Pradesh and Uttar Pradesh. In these forests, plants remain leafless for most part of the year and give an expression of scrub vegetation. Important species found are babul, bur, and wild date palm, care, neem, kedri, palas, etc. Tussocky grass grows up to a height of 2 meters as the undergrowth. Montane forests. In mountainous areas, the decrease in temperature with increasing altitude leads to a corresponding change in natural vegetation. Mountain forests can be classified into two types, the northern mountain forests and the southern mountain forests. The Himalayan ranges show a succession of vegetation from the tropical to the tundra, which change in with the altitude. Deciduous forests are found in the foothills of the Himalayas. It is succeeded by the wet temperate type of forests between an altitude of 1,000 to 2,000 m. In the higher hill ranges of northeastern India, hilly areas of West Bengal and Uttaranchal, evergreen broadleaf trees such as oak and chestnut are predominant. Between 1,500,1,750 meters, pine forests are also well developed in this zone, with sheer pine as a very useful commercial tree. Deodar, a highly valued endemic species, grows mainly in the western part of the Himalayan range. Deodar is a durable wood mainly used in construction activity. Similarly, the chinar and the walnut, which sustain the famous Kashmir handicrafts, belong to this zone. Blue pine and spruce appear at altitudes of 2,253,048 meters. At many places in this zone, temperate grasslands are also found. But in the higher reaches there is a transition to alpine forests and pastures. Silver firs, junipers, pines, birch and rhododendrons, etc. occur between 3,000–4,000 m. However, these pastures are used extensively for transhumance by tribes like the Gujars, the Bakarwals, the Bhotias and the Gaddis. The southern slopes of the Himalayas carry a thicker vegetation cover because of relatively higher precipitation than the drier north-facing slopes. At higher altitudes, mosses and lichens form part of the tundra vegetation. The southern mountain forests include the forests found in three distinct areas of peninsular India, viz., the Western Ghats, the Vindhyas and the Nilgiris. As they are closer to the tropics, and only 1,500 meters above the sea level, vegetation is temperate in the higher regions, and subtropical on the lower regions of the Western Ghats, especially in Kerala, Tamil Nadu and Karnataka. The temperate forests are called sholas in the Nilgiris, Anaimalai and Palani hills. Some of the other trees of this forest of economic significance include magnolia, laurel, cinchona and wattle. Such forests are also found in the Satpura and the Michael ranges. Littoral and swamp forests. India has a rich variety of wetland habitats. About 70% of this comprises areas under paddy cultivation. The total area of wetland is 3.9 million hectares. Two sites, Chilika Lake, Orissa, and Keoladeo National Park, Bharatpur, are protected as waterfowl habitats under the Convention of Wetlands of International Importance, Ramsar Convention. The country's wetlands have been grouped into 8 categories, viz. I. The reservoirs of the Deccan Plateau in the south together with the lagoons and other wetlands of the southern west coast. 2. The vast saline expanses of Rajasthan, Gujarat and the Gulf of Kachch. 3. Freshwater lakes and reservoirs from Gujarat eastwards through Rajasthan, Keoladeo National Park, and Madhya Pradesh. 4. The delta wetlands and lagoons of India's east coast, Chilika Lake. 5. The freshwater marshes of the Gangetic Plain. 6. The floodplains of the Brahmaputra, the marshes and swamps in the hills of northeast India and the Himalayan foothills. 7. The lakes and rivers of the montane region of Kashmir and Ladakh, and 8. The mangrove forest and other wetlands of the island arcs of the Andaman and Nicobar Islands. Mangroves grow along the coasts in the salt marshes, tidal creeks, mudflats and estuaries. They consist of a number of salt-tolerant species of plants. Crisscrossed by creeks of stagnant water and tidal flows, these forests give shelter to a wide variety of birds. In India, the mangrove forests spread over 6,740 square kilometer, which is 7% of the world's mangrove forests. They are highly developed in the Andaman and Nicobar Islands and the Sundarbans of West Bengal. Other areas of significance are the Mahanadi, the Godavari and the Krishna deltas. These forests, too, are being encroached upon, and hence, need conservation. Forest cover in India. According to state records, the forest area covers 23.28% of the total land area of the country. It is important to note that the forest area and the actual forest cover are not the same. The forest area is the area notified and recorded as the forest land irrespective of the existence of trees, while the actual forest cover is the area occupied by forests with canopy. The former is based on the records of the State Revenue Department, while the latter is based on aerial photographs and satellite imageries. In 2001, the actual forest cover was only 20.55%. Of the forest cover, the share of dense and open forests was 12.60% and 7.87% respectively. Both forest area and forest cover vary from state to state. Lakshadweep has 0% forest area, Andaman and Nicobar Islands have 86.93%. Most of the states with less than 10% of the forest area lie in the north and northwestern part of the country. These are Rajasthan, Gujarat, Punjab, Haryana and Delhi. Most of the forests in Punjab and Haryana have been cleared for cultivation. States with 10–20% forest area are Tamil Nadu and West Bengal. In peninsular India, excluding Tamil Nadu, Dadra and Nagar Haveli and Goa, the area under forest cover is 20–30%. The northeastern states have more than 30% of the land under forest. Hilly topography and heavy rainfall are good for forest growth. There is a lot of variation in actual forest cover, which ranges from 9.56% in Jammu and Kashmir to 84.01% in Andaman and Nicobar Islands. From the table showing the distribution of forests in India, Appendix 4, it is clear that there are 15 states where the forest cover is more than a third of the total area, which is the basic requirement for maintaining the ecological balance. On the basis of the percentage of the actual forest cover, the states have been grouped into 4 regions. The region percentage cover of the forest. 1. The region of high concentration greater than 40. 2. The region of medium concentration 20–40. 3. The region of low concentration 10–20. 4. The region of very low concentration less than 10. Forest conservation. Forests have an intricate interrelationship with life and environment. These provide numerous direct and indirect advantages to our economy and society. Hence, conservation of forest is of vital importance to the survival and prosperity of humankind. Accordingly, the Government of India proposed to have a nationwide forest conservation policy, and adopted a forest policy in 1952, which was further modified in 1988. According to the new forest policy, the government will emphasize sustainable forest management in order to conserve and expand forest reserve on the one hand, and to meet the needs of local people on the other. The forest policy aimed at bringing 33% of the geographical areas under forest cover, 2. Maintaining environmental stability and to restore forests where ecological balance was disturbed, 3. Conserving the natural heritage of the country, its biological diversity and genetic pool, 4. Check soil erosion, extension of the desert lands and reduction of floods and droughts, 5. Increasing the forest cover through social forestry and afforestation on degraded land, 6. Increasing the productivity of forests to make timber, fuel, fodder and food available to rural population dependent on forests, and encourage the substitution of wood, 7. Creating of a massive people's movement involving women to encourage planting of trees, stop felling of trees and thus, reduce pressure on the existing forest. Based on the forest conservation policy, the following steps were initiated. Social forestry. Social forestry means the management and protection of forests and afforestation on barren lands with the purpose of helping in the environmental, social and rural development. The National Commission on Agriculture, 1976, has classified social forestry into 3 categories. These are urban forestry, rural forestry and farm forestry. Urban forestry pertains to the raising and management of trees on public and privately owned lands in and around urban centers such as green belts, parks, roadside avenues, industrial and commercial green belts, etc. Rural forestry lays emphasis on promotion of agroforestry and community forestry. Agroforestry is the raising of trees and agriculture crops on the same land inclusive of the waste patches. It combines forestry with agriculture, thus, altering the simultaneous production of food, fodder, fuel, timber and fruit. Community forestry involves the raising of trees on public or community land such as the village pasture and temple land, roadside, canal bank, strips along railway lines, and schools etc. Community forestry program aims at providing benefits to the community as a whole. Community forestry provides a means under which the people of landless classes can associate themselves in tree raising and thus, get those benefits which otherwise are restricted for landowners. Farm forestry. Farm forestry is a term applied to the process under which farmers grow trees for commercial and non-commercial purposes on their farm lands. Forest departments of various states distribute seedlings of trees free of cost to small and medium farmers. Several lands such as the margins of agricultural fields, grasslands and pastures, land around homes and cow sheds may be used for raising trees under non-commercial farm forestry. Wildlife. You would have visited a zoo and may have seen animals and birds in captivity. Wildlife of India is a great natural heritage. It is estimated that about 4 to 5% of all known plant and animal species on the earth are found in India. The main reason for this remarkable diversity of life forms is the great diversity of the ecosystem which this country has preserved and supported through the ages. Over the years, their habitat has been disturbed by human activities and as a result, their numbers have dwindled significantly. There are certain species that are at the brink of extinction. Some of the important reasons of the declining of wildlife are as follows. 1. Industrial and technological advancement brought about a rapid increase in the exploitation of forest resources. 2. More and more lands were cleared for agriculture, human settlement, roads, mining, reservoirs, etc. 3. Pressure on forests mounted due to lopping for fodder and fuel wood and removal of small timber by the local people. 4. Grazing by domestic cattle caused an adverse effect on wildlife and its habitat. 5. Hunting was taken up as a sport by the elite and hundreds of wild animals were killed in a single hunt. Now commercial poaching is rampant. 6. Incidents of forest fire. It is being felt that conservation of wildlife is of great significance to the national as well as the world heritage along with the promotion of ecotourism. What steps have been initiated by the government in this direction? Wildlife conservation in India. The protection of wildlife has a long tradition in India. Many stories of Panchtantra and jungle books, etc., have stood the test of time relating to the love for wildlife. These have a profound impact on young minds. Enacted, which provides the main legal framework for conservation and protection of wildlife in India. The two main objectives of the Act are, to provide protection to the endangered species listed in the schedule of the Act and to provide legal support to the conservation areas of the country classified as national parks, sanctuaries and closed areas. This act has been comprehensively amended in 1991, making punishments more stringent and has also made provisions for the protection of specified plant species and conservation of endangered species of wild animals. There are 92 national parks and 492 wildlife sanctuaries covering an area of 15.67 million hectares in the country. Wildlife conservation has a very large ambit with unbounded potential for the well-being of humankind. However, this can be achieved only when every individual understands its significance and contributes his bit. For the purpose of effective conservation of flora and fauna, special steps have been initiated by the Government of India in collaboration with UNESCO's Man and Biosphere program. Special schemes like Project Tiger, 1973, and Project Elephant, 1992, have been launched to conserve these species and their habitat in a sustainable manner. Project Tiger has been implemented since 1973. The main objective of the scheme is to ensure maintenance of viable population of tigers in India for scientific, aesthetic, cultural and ecological values, and to preserve areas of biological importance as natural heritage for the benefit, education and enjoyment of the people. Initially, the Project Tiger was launched in 9 tiger reserves, covering an area of 16,339 square kilometer, which has now increased to 27 tiger reserves, encompassing 37,761 square kilometer of tiger habitats distributed in 17 states. The tiger population in the country has registered an increase from 1,827 in 1972 to 3,642 in 2001-2002. Project Elephant was launched in 1992 to assist states having free-ranging population of wild elephants. It was aimed at ensuring long-term survival of identified viable population of elephants in their natural habitat. The project is being implemented in 13 states. Apart from this, some other projects such as Crocodile Breeding Project, Project Hongal and Conservation of Himalayan musk deer have also been launched by the Government of India. Biosphere Reserves. A biosphere reserve is a unique and representative ecosystem of terrestrial and coastal areas which are internationally recognized within the framework of UNESCO's Man and Biosphere (MAB) program. The Biosphere Reserve aims at achieving the 3 objectives as depicted in Figure 5.8. There are 14 biosphere reserves in India, Table 5.1, Figure 5.9. Serial No. Name of the biosphere. Geographical area in square kilometer. Date of designation. Location in the states, UT. 1. Nilgiri. 5520. The 8th of January 1986. Part of Wayanad, Nagarhole, Bandipur and Madumalai, Nelambar, Silent Valley and Saruvani Hills, Tamil Nadu, Kerala and Karnataka. 2. Nanda Devi. 5860.69. The 18th of January 1988. Part of Chamoli, Pithoragarh and Almora districts in Uttarakhand. 3. Nokrek. 820-01.09.1988. Part of East, West and South Garo Hill districts in Meghalaya. 4. Manas. 2837. The 14th of March 1989. Part of Kokrajhar, Bangagaon, Barpeta, Nalbari, Kamrup and Darang districts in Assam. 5. Sundarban. 9630, the 29th of March 1989. Part of Delta of Ganges and Brahmaputra river system in West Bengal. 6. Gulf of Mannar. 10,500. The 18th of February 1989. Indian part of Gulf of Mannar extending from Rameswaram Island in the north to Kanyakumari in the south of Tamil Nadu. 7. Great Nicobar. 885. The 1st of June 1989. Southernmost island of Andaman and Nicobar Islands. 8. Similipal. 4374. The 21st of June 1994. Part of Mayurbhanj district in Odisha. 9. Dibru-Sakhowal. 765. The 28th of July 1997. Part of Dibrugarh and Tinsukia districts in Assam. 10. Dihang Dabang. 5111.5. The 9th of February 1998. Part of Upper Siang, West Siang and Dabang Valley districts in Arunachal Pradesh. 11. Pachmarhi. 4981.72. The 3rd of March 1999. Part of Batul, Hoshangabad and Chhindwara districts in Madhya Pradesh. 12. Kangchenjunga. 2619.92. The 2nd of July 2000. Part of North and West districts in Sikkim. 13. Agastyamalai. 3500.36. The 11th of December 2001. Part of Thirunelveli and Kanyakumari districts in Tamil Nadu and Tiruvananthapuram, Kollam and Pathanthita districts. In Kerala. 14. Achanak Maramarkantik. 3835.51. The 30th of March 2005. Part of Anupur and Dindori districts of Madhya Pradesh and Bilaspur district of Chhattisgarh. 15. Kachich. 12,454. The 29th of January 2008. Part of Kachich, Raikot, Surendranagar and Patan districts in Gujarat. 16. Cold Desert. 7,770. The 28th of August 2009. Pin Valley National Park and surroundings, Chandradal and Sarchu and Kibber Wildlife Sanctuary in Himachal Pradesh. 17. Seshachalam. 4,755.997. The 20th of September 2010. Seshachalam Hill Ranges in eastern Ghats encompassing part of Chittor and Kadapa districts in Andhra Pradesh. 18. Panna. 2,998.98. The 25th of August 2011. Part of Pan and Chhattarpur districts in Madhya Pradesh. Nilgiri Biosphere Reserve. The Nilgiri Biosphere Reserve, NBR, the first of the 14 biosphere reserves of India, was established in September 1986. It embraces the sanctuary complex of Wayanad, Nagarhole, Bandipur and Mudumalai, the entire forested hill slopes of Nilambur, the upper Nilgiri Plateau, Silent Valley and the Saruvani Hills. The total area of the Biosphere Reserve is around 5,520 square kilometer. The Nilgiri Biosphere Reserve possesses different habitat types, unspoiled areas of natural vegetation types with several dry scrubs, dry and moist deciduous, semi-evergreen and wet evergreen forests, evergreen sholas, grasslands and swamps. It includes the largest known population of two endangered animal species, namely the Nilgiri tahr and the lion-tailed macaque. The largest South Indian population of elephant, tiger, gaur, sambar and chital as well as a good number of endemic and endangered plants are also found in this reserve. The habitat of a number of tribal groups remarkable for their traditional modes of harmonious use of the environment are also found here. The topography of the NBR is extremely varied, ranging from an altitude of 250 meters to 2,650 meters. About 80% of the flowering plants reported from the Western Ghats occur in the Nilgiri Biosphere Reserve. Nanda Devi Biosphere Reserve. The Nanda Devi Biosphere Reserve situated in Uttaranchal includes parts of Chamoli, Almora, Pithoragarh and Bageshwar districts. The major forest types of the reserve are temperate. A few important species are silver weed and orchids like latifolia and rhododendron. The Biosphere Reserve has a rich fauna, for example the snow leopard, black bear, brown bear, musk deer, snowcock, golden eagle and black eagle. Major threats to the ecosystem are the collection of endangered plants for medicinal use, forest fires and poaching. Sundarbans Biosphere Reserve. It is located in the swampy delta of the river Ganga in West Bengal. It extends over a vast area of 9,630 square kilometer and consists of mangrove forests, swamps and forested islands. Sundarbans is the home of nearly 200 Royal Bengal tigers. The tangled mass of roots of mangrove trees provide safe homes for a large number of species, from fish to shrimp. More than 170 bird species are known to inhabit these mangrove forests. Adapting itself to the saline and fresh water environment, the tigers at the park are good swimmers, and they hunt scarce prey such as chital deer, barking deer, wild pig and even macaques. In the Sundarbans, the mangrove forests are characterized by Heratira fomes, a species valued for its timber. Gulf of Mannar Biosphere Reserve. The Gulf of Mannar Biosphere Reserve covers an area of 105,000 hectares on the southeast coast of India. It is one of the world's richest regions from a marine biodiversity perspective. The Biosphere Reserve comprises 21 islands with estuaries, beaches, forests of the nearshore environment, sea grasses, coral reefs, salt marshes and mangroves. Among the Gulf's 3,600 plant and animal species are the globally endangered sea cow, dugong dugong, and 6 mangrove species, endemic to peninsular India. Forest and life. To a vast number of tribal people, the forest is a home, a livelihood, their very existence. It provides them food, fruits of all kinds, edible leaves, honey, nourishing roots and wild game. It provides them with material to build their houses and items for practicing their arts. The importance of forests in tribal economy is well known as they are the source of sustenance and livelihood for tribal communities. It is commonly believed that the tribal communities live in harmony with nature and protect forests. Out of a total of 593 districts, 187, 2001, have been identified as tribal districts. The tribal districts account for about 59.8% of the total forest cover of the country, whereas the geographical area of 187 tribal districts forms only 33.6% of the total geographical area of the country. It demonstrates that tribal districts are generally rich in forest cover. Forest and tribals are very closely related. The age-old knowledge of tribals regarding forestry can be used in the development of forests. Rather than treating tribals as minor forest produce collectors, they should be made growers of minor forest produce and encouraged to participate in conservation. Chapter 6. Soils. Have you ever thought about the most important factor which supports trees, grasses, crops and numerous life forms over the Earth's surface? Can one grow a blade of grass without soil? While some plants and organisms which are aquatic in nature can sustain in water, do they not derive nutrients from soil through water? You will realize that soil is the most important layer of the Earth's crust. It is a valuable resource. The bulk of our food and much of our clothing is derived from land-based crops that grow in the soil. The soil on which we depend so much for our day-to-day needs has evolved over thousands of years. The various agents of weathering and gradation have acted upon the parent rock material to produce a thin layer of soil. Soil is the mixture of rock debris and organic materials which develop on the Earth's surface. The major factors affecting the formation of soil are relief, parent material, climate, vegetation and other life forms and time. Besides these, human activities also influence it to a large extent. Components of the soil are mineral particles, humus, water and air. The actual amount of each of these depend upon the type of soil. Some soils are deficient in one or more of these, while there are some others that have varied combinations. Have you ever dug a pit in the field of your school to plant a tree while celebrating Vanmahotsava? Was the pit of uniform layer of soil, or did you notice different colors from the top to the bottom of the pit? If we dig a pit on land and look at the soil, we find that it consists of 3 layers which are called horizons. Horizon A is the topmost zone, where organic materials have got incorporated with the mineral matter, nutrients and water, which are necessary for the growth of plants. Horizon B is a transition zone between the Horizon A and Horizon C, and contains matter derived from below as well as from above. It has some organic matter in it, although the mineral matter is noticeably weathered. Horizon C is composed of the loose parent material. This layer is the first stage in the soil formation process and eventually forms the above two layers. This arrangement of layers is known as the soil profile. Underneath these three horizons is the rock, which is also known as the parent rock or the bedrock. Soil, which is a complex and varied entity, has always drawn the attention of the scientists. In order to understand its importance, it is essential to attempt a scientific study of the soil. Classification of the soil is an effort to achieve this objective. Classification of soils. India has varied relief features, landforms, climatic realms, and vegetation types. These have contributed in the development of various types of soils in India. In ancient times, soils used to be classified into two main groups, Urvara and Usara, which were fertile and sterile, respectively. In the 16th century AD, soils were classified on the basis of their inherent characteristics and external features such as texture, color, slope of land, and moisture content in the soil. Based on texture, main soil types were identified as sandy, clayey, silty, and loam, etc. On the basis of color, they were red, yellow, black, etc. Since independence, scientific surveys of soils have been conducted by various agencies. Soil Survey of India, established in 1956, made comprehensive studies of soils in selected areas like in the Damodar Valley. The National Bureau of Soil Survey and the Land Use Planning and Institute under the control of the Indian Council of Agricultural Research, ICAR, did a lot of studies on Indian soils. In their effort to study soil and to make it comparable at the international level, the ICAR has classified the Indian soils on the basis of their nature and character as per the United States Department of Agriculture, USDA, soil taxonomy. On the basis of genesis, color, composition, and location, the soils of India have been classified into 1. Alluvial soils, 2. Black soils, 3. Red and yellow soils, 4. Laterite soils, 5. Arid soils, 6. Saline soils, 7. Peaty soils, 8. Forest soils. Alluvial soils. Alluvial soils are widespread in the northern plains and the river valleys. These soils cover about 40% of the total area of the country. They are depositional soils, transported and deposited by rivers and streams. Through a narrow corridor in Rajasthan, they extend into the plains of Gujarat. In the peninsular region, they are found in deltas of the east coast and in the river valleys. The alluvial soils vary in nature from sandy loam to clay. They are generally rich in potash but poor in phosphorus. In the upper and middle Ganga plain, two different types of alluvial soils have developed, viz. Khadar and Bangar. Khadar is the new alluvium and is deposited by floods annually, which enriches the soil by depositing fine silts. Bangar represents a system of older alluvium, deposited away from the flood plains. Both the Khadar and Bangar soils contain calcareous concretions, cankers. These soils are more loamy and clayey in the lower and middle Ganga plain and the Brahmaputra valley. The sand content decreases from the west to east. The color of the alluvial soils varies from the light gray to ash gray. Its shades depend on the depth of the deposition, the texture of the materials, and the time taken for attaining maturity. Alluvial soils are intensively cultivated. Black soil. Black soil covers most of the Deccan Plateau, which includes parts of Maharashtra, Madhya Pradesh, Gujarat, Andhra Pradesh, and some parts of Tamil Nadu. In the upper reaches of the Godavari and the Krishna, and the north western part of the Deccan Plateau, the black soil is very deep. These soils are also known as the Rigor soil, or the black cotton soil. The black soils are generally clayey, deep and impermeable. They swell and become sticky when wet and shrink when dried. So, during the dry season, these soil develop wide cracks. Thus, there occurs a kind of self-plowing. Because of this character of slow absorption and loss of moisture, the black soil retains the moisture for a very long time, which helps the crops, especially the rain-fed ones, to sustain even during the dry season. Chemically, the black soils are rich in lime, iron, magnesia and alumina. They also contain potash, but they lack in phosphorus, nitrogen and organic matter. The color of the soil ranges from deep black to gray. Red and yellow soil. Red soil develops on crystalline igneous rocks in areas of low rainfall in the eastern and southern part of the Deccan Plateau. Along the Piedmont zone of the Western Ghats, long stretch of area is occupied by red loamy soil. Yellow and red soils are also found in parts of Orissa and Chhattisgarh and in the southern parts of the Middle Ganga Plain. The soil develops a reddish color due to a wide diffusion of iron in crystalline and metamorphic rocks. It looks yellow when it occurs in a hydrated form. The fine-grained red and yellow soils are normally fertile, whereas coarser-grained soils found in dry upland areas are poor in fertility. They are generally poor in nitrogen, phosphorus and humus. Laterite soil. Laterite has been derived from the Latin word later, which means brick. The laterite soils develop in areas with high temperature and high rainfall. These are the result of intense leaching due to tropical rains. With rain, lime and silica are leached away, and soils rich in iron oxide and aluminium compound are left behind. Humus content of the soil is removed fast by bacteria that thrives well in high temperature. These soils are poor in organic matter, nitrogen, phosphate and calcium, while iron oxide and potash are in excess. Hence, laterites are not suitable for cultivation. However, application of manures and fertilizers are required for making the soils fertile for cultivation. Red laterite soils in Tamil Nadu, Andhra Pradesh and Kerala are more suitable for tree crops like cashew nut. Laterite soils are widely cut as bricks for use in house construction. These soils have mainly developed in the higher areas of the peninsular plateau. The laterite soils are commonly found in Karnataka, Kerala, Tamil Nadu, Madhya Pradesh and the hilly areas of Orissa and Assam. Arid soils. Arid soils range from red to brown in color. They are generally sandy in structure and saline in nature. In some areas, the salt content is so high that common salt is obtained by evaporating the saline water. Due to the dry climate, high temperature and accelerated evaporation, they lack moisture and humus. Nitrogen is insufficient and the phosphate content is normal. Lower horizons of the soil are occupied by canker layers because of the increasing calcium content downwards. The canker layer formation in the bottom horizons restricts the infiltration of water, and as such when irrigation is made available, the soil moisture is readily available for a sustainable plant growth. Arid soils are characteristically developed in western Rajasthan, which exhibit characteristic arid topography. These soils are poor and contain little humus and organic matter. Saline soils. They are also known as Usara soils. Saline soils contain a larger proportion of sodium, potassium and magnesium, and thus, they are infertile, and do not support any vegetative growth. They have more salts, largely because of dry climate and poor drainage. They occur in arid and semi-arid regions, and in waterlogged and swampy areas. Their structure ranges from sandy to loamy. They lack in nitrogen and calcium. Saline soils are more widespread in western Gujarat deltas of the eastern coast and in Sundarban areas of West Bengal. In the Rann of Kutch, the southwest monsoon brings salt particles and deposits there as a crust. Seawater intrusions in the deltas promote the occurrence of saline soils. In the areas of intensive cultivation with excessive use of irrigation, especially in areas of green revolution, the fertile alluvial soils are becoming saline. Excessive irrigation with dry climatic conditions promotes capillary action, which results in the deposition of salt on the top layer of the soil. In such areas, especially in Punjab and Haryana, farmers are advised to add gypsum to solve the problem of salinity in the soil. Peaty soils. They are found in the areas of heavy rainfall and high humidity, where there is a good growth of vegetation. Thus, large quantity of dead organic matter accumulates in these areas, and this gives a rich humus and organic content to the soil. Organic matter in these soils may go even up to 4,050%. These soils are normally heavy and black in color. At many places, they are alkaline also. It occurs widely in the northern part of Bihar, southern part of Uttaranchal and the coastal areas of West Bengal, Orissa and Tamil Nadu. Forest soils. As the name suggests, forest soils are formed in the forest areas where sufficient rainfall is available. The soils vary in structure and texture depending on the mountain environment where they are formed. They are loamy and silty on valley sides and coarser-grained in the upper slopes. In the snowbound areas of the Himalayas, they experience denudation, and are acidic with low humus content. The soils found in the lower valleys are fertile. It is evident from the foregoing discussions that soils, their texture, quality and nature are vital for the germination and growth of plant and vegetation including crops. Soils are living systems. Like any other organism, they too develop and decay, get degraded, respond to proper treatment if administered in time. These have serious repercussions on other components of the system of which they themselves are important parts. Soil degradation. In a broad sense, soil degradation can be defined as the decline in soil fertility, when the nutritional status declines and depth of the soil goes down due to erosion and misuse. Soil degradation is the main factor leading to the depleting soil resource base in India. The degree of soil degradation varies from place to place according to the topography, wind velocity and amount of the rainfall. Soil erosion. The destruction of the soil cover is described as soil erosion. The soil-forming processes and the erosional processes of running water and wind go on simultaneously. But generally, there is a balance between these two processes. The rate of removal of fine particles from the surface is the same as the rate of addition of particles to the soil layer. Sometimes, such a balance is disturbed by natural or human factors, leading to a greater rate of removal of soil. Human activities too are responsible for soil erosion to a great extent. As the human population increases, the demand on the land also increases. Forest and other natural vegetation is removed for human settlement, for cultivation, for grazing animals and for various other needs. Wind and water are powerful agents of soil erosion because of their ability to remove soil and transport it. Wind erosion is significant in arid and semi-arid regions. In regions with heavy rainfall and steep slopes, erosion by running water is more significant. Water erosion, which is more serious and occurs extensively in different parts of India, takes place mainly in the form of sheet and gully erosion. Sheet erosion takes place on level lands after a heavy shower and the soil removal is not easily noticeable. But it is harmful since it removes the finer and more fertile topsoil. Gully erosion is common on steep slopes. Gullies deepen with rainfall, cut the agricultural lands into small fragments and make them unfit for cultivation. A region with a large number of deep gullies or ravines is called a badland topography. Ravines are widespread, in the Chambal Basin. Besides this, they are also found in Tamil Nadu and West Bengal. The country is losing about 8,000 hectares of land to ravines every year. What types are prone to gully erosion? Soil erosion is a serious problem for Indian agriculture and its negative effects are seen in other spheres also. Eroded materials are carried down to rivers and they lower down their carrying capacity, and cause frequent floods and damage to agricultural lands. Deforestation is one of the major causes of soil erosion. Plants keep soils bound in locks of roots, and thus, prevent erosion. They also add humus to the soil by shedding leaves and twigs. Forests have been denuded practically in most parts of India, but their effect on soil erosion are more in hilly parts of the country. A fairly large area of arable land in the irrigated zones of India is becoming saline because of over-irrigation. The salt lodged in the lower profiles of the soil comes up to the surface and destroys its fertility. Chemical fertilizers in the absence of organic manures are also harmful to the soil. Unless the soil gets enough humus, chemicals harden it and reduce its fertility in the long run. This problem is common in all the command areas of the river valley projects, which were the first beneficiaries of the Green Revolution. According to estimates, about half of the total land of India is under some degree of degradation. Every year, India loses millions of tons of soil and its nutrients to the agents of its degradation, which adversely affects our national productivity. So, it is imperative to initiate immediate steps to reclaim and conserve soils. Soil conservation. If soil erosion and exhaustion are caused by humans, by corollary, they can also be prevented by humans. Nature has its own laws of maintaining balance. Nature offers enough opportunities for humans to develop their economy without disturbing the ecological balance. Soil conservation is a methodology to maintain soil fertility, prevent soil erosion and exhaustion, and improve the degraded condition of the soil. Soil erosion is essentially aggravated by faulty practices. The first step in any rational solution is to check open cultivable lands on slopes from farming. Lands with a slope gradient of 15–25% should not be used for cultivation. If at all the land is to be used for agriculture, terraces should carefully be made. Overgrazing and shifting cultivation in many parts of India have affected the natural cover of land and given rise to extensive erosion. It should be regulated and controlled by educating villagers about the consequences. Contour bunding, contour terracing, regulated forestry, controlled grazing, cover cropping, mixed farming and crop rotation are some of the remedial measures which are often adopted to reduce soil erosion. Efforts should be made to prevent gully erosion and control their formation. Finger gullies can be eliminated by terracing. In bigger gullies, the erosive velocity of water may be reduced by constructing a series of check dams. Special attention should be made to control headward extension of gullies. This can be done by gully plugging, terracing or by planting cover vegetation. In arid and semi-arid areas, efforts should be made to protect cultivable lands from encroachment by sand dunes through developing shelter belts of trees and agroforestry. Lands not suitable for cultivation should be converted into pastures for grazing. Experiments have been made to stabilize sand dunes in western Rajasthan by the Central Arid Zone Research Institute, CAZRI. The Central Soil Conservation Board, set up by the Government of India, has prepared a number of plans for soil conservation in different parts of the country. These plans are based on the climatic conditions, configuration of land and the social behavior of people. Even these plans are fragmental in nature. Integrated land use planning, therefore, seems to be the best technique for proper soil conservation. Lands should be classified according to their capability, land use maps should be prepared and lands should be put to right uses. The final responsibility for achieving the conservation of land will rest on the people who operate on it and receive the benefits. Unit 4. Natural hazards and disasters. Causes, consequences and management. This unit deals with floods and droughts, earthquakes and tsunami, cyclones, landslides. Chapter 7. Natural hazards and disasters. You might have read about tsunami or seen the images of horror on television set immediately after it happened. You may also be aware of the severe earthquake in Kashmir on both sides of the line of control lock. The damage caused to human life and properties during these episodes has moved us all. What are these as phenomena and how they are caused? How can we save ourselves? These are some questions which come to our minds. This chapter will attempt to analyze some of these questions. Change is the law of nature. It is a continuous process that goes on uninterruptedly involving phenomena, big and small, material and non-material, that make our physical and socio-cultural environment. It is a process present everywhere with variations in terms of magnitude, intensity and scale. Change can be a gradual or slow process like the evolution of landforms and organisms, and it can be as sudden and swift as volcanic eruptions, tsunamis, earthquakes and lightning, etc. Similarly, it may remain confined to a smaller area occurring within a few seconds like hailstorms, tornadoes and dust storms, and it can also have global dimensions such as global warming and depletion of the ozone layer. Besides, these changes have different meanings for different people. It depends upon the perspective one takes while trying to understand them. From the perspective of nature, changes are value neutral, these are neither good nor bad. But from the human perspective, these are value loaded. There are some changes that are desirable and good, like the change of seasons, ripening of fruits, while there are others like earthquakes, floods and wars that are considered bad and undesirable. In this chapter, we will read about some of these changes, which are considered bad and have haunted humankind for a long time. Disasters in general and natural disasters in particular are some such changes that are always disliked and feared by humankind. For a long time, geographical literature viewed disasters as a consequence of natural forces, and human beings were treated as innocent and helpless victims in front of the mighty forces of nature. But natural forces are not the only causes of disasters. Disasters are also caused by some human activities. There are some activities carried by human beings that are directly responsible for disasters. Bhopal gas tragedy, Chernobyl nuclear disaster, wars, release of CFCs, chlorofluorocarbons, an increase of greenhouse gases, environmental pollutions like noise, air, water and soil are some of the disasters which are caused directly by human actions. There are some other activities of human beings that accelerate or intensify disasters indirectly. Landslides and floods due to deforestation, unscientific land use and construction activities in fragile areas are some of the disasters that are the results of indirect human actions. Can you identify some other human activities going on in and around your neighborhood and schools that can lead to disasters in the near future? Can you suggest some measures to prevent it? It is a common experience that human-made disasters have increased both in their numbers and magnitudes over the years, and concerted efforts are on at various levels to prevent and minimize their occurrences. Though the success has been only nominal so far, it is possible to prevent some of these disasters created by human actions. As opposed to this, very little is possible to prevent natural disasters. Therefore, the best way out is to emphasize on natural disaster mitigation and management. Establishment of National Institute of Disaster Management, India, Earth Summit at Rio de Janeiro, Brazil, 1993, and the World Conference on Disaster Management in May 1994 at Yokohama, Japan, etc. are some of the concrete steps towards this direction initiated at different levels. Most often it is observed that scholars use disasters and natural hazards as interchangeable. Both are related phenomena, yet quite distinct from each other. Hence, it is necessary to distinguish between the two. Natural hazards are elements of circumstances in the natural environment that have the potential to cause harm to people or property or both. These may be swift or permanent aspects of the respective environmental settings like currents in the oceans, steep slope and unstable structural features in the Himalayas, or extreme climatic conditions in deserts or glaciated areas. As compared to natural hazards, natural disasters are relatively sudden and cause large-scale, widespread death, loss of property and disturbance to social systems and life over which people have a little or no control. Thus, any event can be classed as disaster when the magnitude of destruction and damage caused by it is very high. Generally, disasters are generalized experiences of people the world over, and no two disasters are similar and comparable to each other. Every disaster is unique in terms of the local socio-environmental factors that control it, the social response it generates, and the way each social group negotiates with it. However, the opinion mentioned above is indicative of three important things. Firstly, the magnitude, intensity, frequency and damages caused by natural disasters have increased over the years. Secondly, there is a growing concern among people the world over to deal with the menace created by these so that the loss of human life and property can be minimized. And finally, significant changes have taken place in the pattern of natural disasters over the years. There has also been a change in the perception of natural disasters and hazards. Previously, hazards and disasters were seen as two closely associated and interrelated phenomena, i.e., areas prone to natural hazards were more vulnerable to disasters. Hence, people avoided tampering with the delicate balance that existed in a given ecosystem. People avoided intensification of their activities in such areas, and that is how disasters were less damaging. Technological power has given large capacity to human intervention in nature. Consequently, now, human beings tend to intensify their activities into disaster-prone areas, increasing their vulnerability to disasters. Colonization of floodplains of most of the rivers and development of large cities and port towns like Mumbai and Chennai along the coast, and touching the shore due to high land values, make them vulnerable to the occurrence of cyclones, hurricanes and tsunamis. These observations can also be corroborated by the data given in Table 7.1 showing the magnitude of deaths caused by 12 serious natural disasters in the past 60 years in different countries of the world. It is evident from the table that natural disasters have caused widespread loss of life and property. Concerted efforts are on at various levels to take appropriate measures to deal with the situation. It is also being felt that the damages caused by natural disasters have global repercussions that are beyond the means and capabilities of individual nation-states to cope up with. Hence, this issue was raised at the UN General Assembly in 1989, and it was finally formalized at the World Conference on Disaster Management in May 1994 at Yokohama, Japan. This was subsequently called the Yokohama Strategy and Plan of Action for a Safer World. Classification of natural disasters. Human beings the world over have experienced disasters and have faced and lived with them. Now people are becoming aware, and various steps have been initiated at different levels for mitigating the effects of disasters. Identification and classification of disasters is being considered as an effective and scientific step to deal promptly and efficiently with the disasters. Broadly, natural disasters can be classified under 4 categories. India is one of those countries which has experienced most of the natural disasters mentioned in Table 7.2. Every year it loses thousands of lives and property worth millions of rupees due to these natural calamities. In the following section, some of the highly devastating natural disasters have been discussed, particularly in the context of India. Natural disasters and hazards in India. It was discussed in one of the previous chapters that India is vast and diverse in terms of its physical and sociocultural attributes. It is largely due to its vast geographical area, environmental diversities and cultural pluralities that scholars often described it using two meaningful adjectives like the Indian subcontinent and the land of unity and diversity. Its vastness in terms of natural attributes combined with its prolonged colonial past, continuing various forms of social discriminations and also equally large population have enhanced its vulnerability to natural disasters. These observations can also be illustrated by focusing on some of the major natural disasters in India. Earthquakes. Earthquakes are by far the most unpredictable and highly destructive of all the natural disasters. You have already learned the causes of earthquakes in your book Fundamentals of Physical Geography, NCERT, 2006. Earthquakes that are of tectonic origin have proved to be the most devastating, and their area of influence is also quite large. These earthquakes result from a series of earth movements brought about by a sudden release of energy during the tectonic activities in the Earth's crust. As compared to these, the earthquakes associated with volcanic eruption, rock fall, landslides, subsidence, particularly in the mining areas, impounding of dams and reservoirs, etc., have limited area of influence and the scale of damage. It was mentioned in Chapter 2 of the book that the Indian plate is moving at a speed of 1 centimeter per year towards the north and northeastern direction, and this movement of plates is being constantly obstructed by the Eurasian plate from the north. As a result of this, both the plates are said to be locked with each other, resulting in accumulation of energy at different points of time. Excessive accumulation of energy results in building up of stress, which ultimately leads to the breaking up of the lock, and the sudden release of energy causes earthquakes along the Himalayan arch. Some of the most vulnerable states are Jammu and Kashmir, Himachal Pradesh, Uttaranchal, Sikkim, and the Darjeeling and subdivision of West Bengal, and all the 7 states of the northeast. Apart from these regions, the central western parts of India, particularly Gujarat, in 1819, 1956 and 2001, and Maharashtra, in 1967 and 1993, have also experienced some severe earthquakes. Earth scientists have found it difficult to explain the occurrence of earthquakes in one of the oldest, most stable and mature landmass of peninsular block for a long time. Recently, some Earth scientists have come up with a theory of emergence of a fault line and energy buildup along the fault line represented by the river Bhima, Krishna, near Lachur and Osmanabad, Maharashtra, and the possible breaking down of the Indian plate, figure 7.2. National Geophysical Laboratory, Geological Survey of India, Department of Meteorology, Government of India, along with the recently formed National Institute of Disaster Management, have made an intensive analysis of more than 1,200 earthquakes that have occurred in India in different years in the past, and based on these, they divided India into the following 5 earthquake zones. 1. Very high damage risk zone. 2. High damage risk zone. 3. Moderate damage risk zone. 4. Low damage risk zone. 5. Very low damage risk zone. Out of these, the first 2 zones had experienced some of the most devastating earthquakes in India. As shown in the figure 7.2, areas vulnerable to these earthquakes are the northeast states, areas to the north of Darbhanga and Araria along the Indo-Nepal border in Bihar, Uttaranchal, western Himachal Pradesh, around Dharamshala, and Kashmir Valley in the Himalayan region and the Kutch Gujarat. These are included in the very high damage risk zone. Similarly, the remaining parts of Jammu and Kashmir, Himachal Pradesh, northern parts of Punjab, eastern parts of Haryana, Delhi, western Uttar Pradesh, and northern Bihar fall under the high damage risk zone. Remaining parts of the country fall under moderate to very low damage risk zone. Most of the areas that can be considered safe are from the stable landmass covered under the Deccan Plateau. Socio-environmental consequences of earthquakes. The idea of an earthquake is often associated with fear and horror due to the scale, magnitude and suddenness at which it spreads disasters on the surface of the earth without discrimination. It becomes a calamity when it strikes the areas of high density of population. It not only damages and destroys the settlements, infrastructure, transport and communication network, industries and other developmental activities but also robs the population of their material and socio-cultural gains that they have preserved over generations. It renders them homeless, which puts an extra pressure and stress, particularly on the weak economy of the developing countries. Effects of earthquakes. Earthquakes have all-encompassing disastrous effects on the area of their occurrence. Some of the important ones are listed in Table 7.3. Apart from these, earthquakes also have some serious and far-reaching environmental consequences. Surface seismic waves produce fissures on the upper layers of the Earth's crust through which water and other volatile materials gush out, inundating the neighboring areas. Earthquakes are also responsible for landslides and often these cause obstructions in the flow of rivers and channels resulting in the formation of reservoirs. Sometimes, rivers also change their course causing floods and other calamities in the affected areas. Table 7.3 – Effects of earthquakes. On ground. Fissures. Settlements. Landslides. Liquefaction. Earth pressure. Possible chain reactions. On man-made structures. Cracking. Sliding. Overturning. Buckling. Collapse. Possible chain effects. On water. Waves. Hydrodynamic pressure. Tsunami. Possible chain effects. Earthquake hazard mitigation. Unlike other disasters, the damages caused by earthquakes are more devastating. Since it also destroys most of the transport and communication links, providing timely relief to the victims becomes difficult. It is not possible to prevent the occurrence of an earthquake, hence, the next best option is to emphasis on disaster preparedness and mitigation rather than curative measures such as 1. Establishing earthquake monitoring centers, seismological centers, for regular monitoring and fast dissemination of information among the people in the vulnerable areas. Use of geographical positioning system (GPS) can be of great help in monitoring the movement of tectonic plates. 2. Preparing a vulnerability map of the country and dissemination of vulnerability risk information among the people and educating them about the ways and means minimizing the adverse impacts of disasters. 3. Modifying the house types and building designs in the vulnerable areas and discouraging construction of high-rise buildings, large industrial establishments and big urban centers in such areas. 4. Finally, making it mandatory to adopt earthquake-resistant designs and use light materials in major construction activities in the vulnerable areas. Tsunami. Earthquakes and volcanic eruptions that cause the seafloor to move abruptly resulting in sudden displacement of ocean water in the form of high vertical waves are called tsunamis, harbor waves, or seismic sea waves. Normally, the seismic waves cause only one instantaneous vertical wave, but, after the initial disturbance, a series of afterwaves are created in the water that oscillate between high crest and low trough in order to restore the water level. The speed of wave in the ocean depends upon the depth of water. It is more in the shallow water than in the ocean deep. As a result of this, the impact of tsunami is less over the ocean and more near the coast where they cause large-scale devastations. Therefore, a ship at sea is not much affected by tsunami and it is difficult to detect a tsunami in the deeper parts of sea. It is so because over deep water the tsunami has very long wavelength and limited wave height. Thus, a tsunami wave raises the ship only a meter or two and each rise and fall takes several minutes. As opposed to this, when a tsunami enters shallow water, its wavelength gets reduced and the period remains unchanged, which increases the wave height. Sometimes, this height can be up to 15 meters or more, which causes large-scale destructions along the shores. Thus, these are also called shallow water waves. Tsunamis are frequently observed along the Pacific Ring of Fire, particularly along the coast of Alaska, Japan, Philippines, and other islands of Southeast Asia, Indonesia, Malaysia, Myanmar, Sri Lanka, and India etc. After reaching the coast, the tsunami waves release enormous energy stored in them and water flows turbulently onto the land, destroying port cities and towns, structures, buildings and other settlements. Since the coastal areas are densely populated the world over, and these are also centers of intense human activity, the loss of life and property is likely to be much higher by a tsunami as compared to other natural hazards in the coastal areas. The extent of devastation caused by tsunami can be assessed through the visuals on Banda Aceh, Indonesia, presented in the book Practical Work in Geography Part 1, NCERT, 2006. Unlike other natural hazards, the mitigation of hazards created by tsunami is difficult, mainly because of the fact that losses are on a much larger scale. It is beyond the capacity of individual state or government to mitigate the damage. Hence, combined efforts at the international levels are the possible ways of dealing with these disasters, as has been in the case of the tsunami that occurred on the 26th of December 2004, in which more than 300,000 people lost their lives. India has volunteered to join the international tsunami warning system after the December 2004 tsunami disaster. Tropical cyclone. Tropical cyclones are intense low-pressure areas confined to the area lying between 30 degrees north and 30 degrees south latitudes, in the atmosphere around which high-velocity winds blow. Horizontally, it extends up to 5,001,000 km and vertically from surface to 1214 km. A tropical cyclone or hurricane is like a heat engine that is energized by the release of latent heat on account of the condensation of moisture that the wind gathers after moving over the oceans and seas. There are differences of opinion among scientists about the exact mechanism of a tropical cyclone. However, some initial conditions for the emergence of a tropical cyclone are: 1. Large and continuous supply of warm and moist air that can release enormous latent heat. 2. Strong Coriolis force that can prevent filling of low pressure at the center. Absence of Coriolis force near the equator prohibits the formation of tropical cyclone between 0 degrees 5 degrees latitude. 3. Unstable condition through the troposphere that creates local disturbances around which a cyclone develops. 4. Finally, absence of strong vertical wind wedge, which disturbs the vertical transport of latent heat. Structure of tropical cyclone. Tropical cyclones are characterized by large pressure gradients. The center of the cyclone is mostly a warm and low-pressure, cloudless core known as eye of the storm. Generally, the isobars are closely placed to each other, showing high-pressure gradients. Normally, it varies between 14-17 MB, 100 km, but sometimes it can be as high as 60 MB, 100 km. Expansion of the wind belt is about 10,150 km from the center. Spatiotemporal distribution of tropical cyclone in India. Owing to its peninsular shape surrounded by the Bay of Bengal in the east and the Arabian Sea in the west, the tropical cyclones in India also originate in these two important locations. Though most of the cyclones originate between 10 degrees 15 degrees north latitudes during the monsoon season, yet in case of the Bay of Bengal, cyclones mostly develop during the months of October and November. Here, they originate between 16 degrees 2 degrees north latitudes and to the west of 92 degrees east. By July, the place of origin of these storms shifts to around 18 degrees north latitude and west of 90 degrees east near the Sundarban Delta. Table 7.4 and Figure 7.4 show the frequency and tracks of time of cyclonic storms in India. Consequences of tropical cyclones. It was mentioned that the energy to the tropical cyclone comes from the latent heat released by the warm moist air. Hence, with the increase in distance from the sea, the force of the cyclone decreases. In India, the force of the cyclone decreases with increase in distance from the Bay of Bengal and the Arabian Sea. So, the coastal areas are often struck by severe cyclonic storms with an average velocity of 180 km/h. Often, this results in abnormal rise in the sea level known as storm surge. This results in inundation of human settlements, agricultural fields, damaging crops and destruction of structures created by human beings. Floods. You read in newspapers and watch images of floods on televisions occurring in some regions during rainy seasons. Inundation of land and human settlements by the rise of water in the channels and its spillover presents the condition of flooding. Unlike other natural disasters, the causes of floods are well established. Floods are relatively slow in occurrences and often occur in well-identified regions and within expected time in a year. Floods occur commonly when water in the form of surface runoff exceeds the carrying capacity of the river channels and streams and flows into the neighboring low-lying floodplains. At times, this even goes beyond the capacity of lakes and other inland water bodies in which they flow. Floods can also be caused due to a storm surge in the coastal areas, high-intensity rainfall for a considerably longer time period, melting of ice and snow, reduction in the infiltration rate and presence of eroded material in the water due to higher rate of soil erosion. Though floods occur frequently over wide geographical area having disastrous ramifications in many parts of the world, floods in the South, Southeast and East Asian countries, particularly in China, India and Bangladesh, are frequent and equally disastrous. Once again, unlike other natural disasters, human beings play an important role in the genesis as well as spread of floods. Indiscriminate deforestation, unscientific agricultural practices, disturbances along the natural drainage channels and colonization of floodplains and riverbeds are some of the human activities that play an important role in increasing the intensity, magnitude and gravity of floods. Various states of India face heavy loss of lives and property due to recurrent floods. Rashtriya Barh National Flood Commission, identified 40 million hectares of land as flood-prone in India. The figure 7.6 shows the flood-affected areas in India. Assam, West Bengal and Bihar are among the high flood-prone states of India. Apart from these, most of the rivers in the northern states like Punjab and Uttar Pradesh are also vulnerable to occasional floods. It has been noticed that states like Rajasthan, Gujarat, Haryana and Punjab are also getting inundated in recent decades due to flash floods. This is partly because of the pattern of the monsoon and partly because of blocking of most of the streams and river channels by human activities. Sometimes, Tamil Nadu experiences flooding during November-January due to the retreating monsoon. Consequence and control of floods. Frequent inundation of agricultural land and human settlement, particularly in Assam, West Bengal, Bihar and eastern Uttar Pradesh, flooding rivers, coastal areas of Orissa, Andhra Pradesh, Tamil Nadu and Gujarat, cyclone, and Punjab, Rajasthan, northern Gujarat and Haryana, flash floods, have serious consequences on the national economy and society. Floods do not only destroy valuable crops every year but these also damage physical infrastructure such as roads, rails, bridges and human settlements. Millions of people are rendered homeless and are also washed down along with their cattle in the floods. Spread of diseases like cholera, gastroenteritis, hepatitis and other waterborne diseases spread in the flood-affected areas. However, floods also make a few positive contributions. Every year, floods deposit fertile silt over agricultural fields, which is good for the crops. Majuli, Assam, the largest riverine island in the world, is the best example of good paddy crops after the annual floods in Brahmaputra. But these are insignificant benefits in comparison to the grave losses. The government of India as well as the state governments are well aware of the menace created by floods every year. How do these governments generally respond to the floods? Construction of flood protection embankments in the flood-prone areas, construction of dams, afforestation and discouraging major construction activities in the upper reaches of most of the flood-creating rivers, etc. are some steps that need to be taken up on urgent basis. Removal of human encroachment from the river channels and depopulating the floodplains can be the other steps. This is particularly true in western and northern parts of the country which experience flash floods. Cyclone centers may provide relief in coastal areas which are hit by a storm surge. Droughts. The term drought is applied to an extended period when there is a shortage of water availability due to inadequate precipitation, excessive rate of evaporation and overutilization of water from the reservoirs and other storages, including the groundwater. Types of droughts. Meteorological drought. It is a situation when there is a prolonged period of inadequate rainfall marked with maldistribution of the same over time and space. Agricultural drought. It is also known as soil moisture drought, characterized by low soil moisture that is necessary to support the crops, thereby resulting in crop failures. Moreover, if an area has more than 30% of its gross cropped area under irrigation, the area is excluded from the drought-prone category. Hydrological drought. It results when the availability of water in different storages and reservoirs like aquifers, lakes, reservoirs, etc. falls below what the precipitation can replenish. Ecological drought. When the productivity of a natural ecosystem fails due to shortage of water and as a consequence of ecological distress, damages are induced in the ecosystem. Various parts of India experience these droughts recurrently, which result in some serious socio-economic and ecological problems. Drought-prone areas in India. Indian agriculture has been heavily dependent on the monsoon rainfall. Droughts and floods are the two accompanying features of Indian climate. According to some estimates, nearly 19% of the total geographical area of the country and 12% of its total population suffer due to drought every year. About 30% of the country's total area is identified as drought-prone, affecting around 50 million people. It is a common experience that while some parts of the country reel under floods, there are regions that face severe drought during the same period. Moreover, it is also a common sight to witness that one region suffers due to floods in one season and experiences drought in the other. This is mainly because of the large-scale variations and unpredictability in the behavior of the monsoon in India. Thus, droughts are widespread and common phenomena in most parts of the country, but these are most recurrent and severe in some and not so in others. On the basis of severity of droughts, India can be divided into the following regions. Extreme drought-affected areas. It is evident from the figure 7.8 that most parts of Rajasthan, particularly areas to the west of the Aravalli Hills, i.e. Marasthali and Kachch regions of Gujarat, fall in this category. Included here are also the districts like Jaisalmer and Barmer from the Indian desert that receive less than 90 mm average annual rainfall. Severe drought-prone area, parts of eastern Rajasthan, most parts of Madhya Pradesh, eastern parts of Maharashtra, interior parts of Andhra Pradesh and Karnataka Plateau, northern parts of interior Tamil Nadu and southern parts of Jharkhand and interior Orissa are included in this category. Moderate drought-affected area, northern parts of Rajasthan, Haryana, southern districts of Uttar Pradesh, the remaining parts of Gujarat, Maharashtra except Konkan, Jharkhand and Coimbatore Plateau of Tamil Nadu and interior Karnataka are included in this category. The remaining parts of India can be considered either free or less prone to the drought. Consequences of drought. Droughts have cascading effects on various other aspects of environment and society. Crop failure leading to scarcity of food grains, akal, fodder, trinkle, inadequate rainfall, resulting in shortage of water, jalkal, and often shortage in all the three, trikal, is most devastating. Large-scale death of cattle and other animals, migration of humans and livestock are the most common sight to be seen in the drought-affected areas. Scarcity of water compels people to consume contaminated water, resulting in spread of many waterborne diseases like gastroenteritis, cholera, hepatitis, etc. Droughts have both immediate as well as long-term disastrous consequences on the social and physical environments. Consequently, planning for drought has to take both aspects into consideration. Provision for the distribution of safe drinking water, medicines for the victims and availability of fodder and water for the cattle and shifting of the people and their livestock to safer places, etc. are some steps that need to be taken immediately. Identification of groundwater potential in the form of aquifers, transfer of river water from the surplus to the deficit areas, and particularly planning for interlinking of rivers and construction of reservoirs and dams, etc. should be given a serious thought. Remote sensing and satellite imageries can be useful in identifying the possible river basins that can be interlinked and in identifying the groundwater potential. Dissemination of knowledge about drought-resistant crops and proper training to practice the same can be some of the long-term measures that will be helpful in drought mitigation. Rainwater harvesting can also be an effective method in minimizing the effects of drought. Landslides. Have you ever read about the blocking of roads to Srinagar or disruption of rail services by stones falling on the Konkan railway track? It happens due to landslide, which is the rapid sliding of large mass of bedrocks. Disasters due to landslides are in general far less dramatic than due to earthquakes, volcanic eruptions, tsunamis and cyclones, but their impact on the natural environment and national economy is in no way less severe. Unlike other disasters that are sudden, unpredictable and are largely controlled by macro or regional factors, landslides are largely controlled by highly localized factors. Hence, gathering information and monitoring the possibilities of landslide is not only difficult but also immensely cost-intensive. It is always difficult to define in a precise statement and generalize the occurrence and behavior of a landslide. However, on the basis of past experiences, frequency and certain causal relationships with the controlling factors like geology, geomorphic agents, slope, land use, vegetation cover and human activities, India has been divided into a number of zones. Landslide vulnerability zones. Very high vulnerability zone, highly unstable, relatively young mountainous areas in the Himalayas and Andaman and Nicobar, high rainfall regions with steep slopes in the western Ghats and Nilgiris, the northeastern regions, along with areas that experience frequent ground shaking due to earthquakes, etc. And areas of intense human activities, particularly those related to construction of roads, dams, etc. are included in this zone. High vulnerability zone, areas that have almost similar conditions to those included in the very high vulnerability zone are also included in this category. The only difference between these two is the combination, intensity and frequency of the controlling factors. All the Himalayan states and the states from the northeastern regions except the plains of Assam are included in the high vulnerability zones. Moderate to low vulnerability zone, areas that receive less precipitation such as Trans-Himalayan areas of Ladakh and Spiti, Himachal Pradesh, undulated yet stable relief and low precipitation areas in the Aravalli, rain shadow areas in the western and eastern Ghats and Deccan Plateau also experience occasional landslides. Landslides due to mining and subsidence are most common in states like Jharkhand, Orissa, Chhattisgarh, Madhya Pradesh, Maharashtra, Andhra Pradesh, Karnataka, Tamil Nadu, Goa and Kerala. Other areas, the remaining parts of India, particularly states like Rajasthan, Haryana, Uttar Pradesh, Bihar, West Bengal, except District Darjeeling, Assam, except District Karbi Anglong, and coastal regions of the southern states are safe as far as landslides are concerned. Consequences of landslides. Landslides have relatively small and localized area of direct influence, but roadblock, destruction of railway lines and channel blocking due to rockfalls have far-reaching consequences. Diversion of river courses due to landslides can also lead to flood and loss of life and property. It also makes spatial interaction difficult, risky as well as a costly affair, which, in turn, adversely affects the developmental activities in these areas. Mitigation. It is always advisable to adopt RE-specific measures to deal with landslides. Restriction on the construction and other developmental activities such as roads and dams, limiting agriculture to valleys and areas with moderate slopes, and control on the development of large settlements in the high vulnerability zones, should be enforced. This should be supplemented by some positive actions like promoting large-scale afforestation programs and construction of bunds to reduce the flow of water. Terrace farming should be encouraged in the northeastern hill states where jumming, slash and burn, shifting cultivation, is still prevalent. Disaster management. Disasters due to cyclones, unlike the ones caused by earthquakes, tsunamis and volcanic eruptions are more predictable in terms of the time and place of their occurrences. Moreover, with the help of development of techniques to monitor the behavior of cyclones, their intensity, direction and magnitude, it has become possible to manage the cyclonic hazard to some extent. Construction of cyclone shelters, embankments, dikes, reservoirs and afforestation to reduce the speed of the winds are some of the steps that can help in minimizing the damages. However, increase in the loss of life and property in countries like India, Bangladesh, Myanmar, etc. in successive storms is largely due to high vulnerability of their population residing in the coastal areas. Conclusion. On the basis of the above discussion, it can be concluded that disasters can be natural or the results of human activities, and all hazards need not turn into disasters since it is difficult to eliminate disasters, particularly natural disasters. Then the next best option is mitigation and preparedness. There are 3 stages involved in disaster mitigation and management. Pre-disaster management involves generating data and information about the disasters, preparing vulnerability zoning maps and spreading awareness among the people about these. Apart from these, disaster planning, preparedness and preventive measures are other steps that need to be taken in the vulnerable areas. 2. During disasters, rescue and relief operations such as evacuation, construction of shelters and relief camps, supplying of water, food, clothing and medical aids etc. should be done on an emergency basis. 3. Post-disaster operations should involve rehabilitation and recovery of victims. It should also concentrate on capacity building in order to cope up with future disasters, if any. These measures have special significance to a country like India, which has about 2/3 of its geographical area and equal proportion of its population, vulnerable to disasters. Introduction of the Disaster Management Bill, 2005 and establishment of National Institute of Disaster Management are some examples of the positive steps taken by the Government of India. What is a disaster? Disaster is an undesirable occurrence resulting from forces that are largely outside human control, strikes quickly with little or no warning, which causes or threatens serious disruption of life and property including death and injury to a large number of people, and requires therefore, mobilization of efforts in excess of that which are normally provided by statutory emergency services. Table 7.1 Top 12 Natural Disasters since 1948. Year. Location. TYP, deaths. 1948. The Soviet Union, now Russia. Earthquakes. Toll 110,000. 1949. China floods. Toll 57,000. 1954. China floods. Toll 30,000. 1965. East Pakistan, now Bangladesh. Tropical cyclones. Toll 36,000. 1968. Iran earthquakes. Toll 30,000. 1970. Peru earthquakes. Toll 66,794. 1970. East Pakistan, now Bangladesh. Tropical cyclones. Toll 500,000. 1971. India tropical cyclones. Toll 30,000. 1976. China earthquakes. Toll 700,000. 1990. Iran earthquakes. Toll 50,000. 2004. Indonesia, Sri Lanka, India, etc. Tsunamis. Toll 500,000. 2005. Pakistan, India. Earthquakes. Toll 70,000. Table 7.2 Classification of natural disasters. Atmospheric. Blizzards. Thunderstorms. Lightning. Tornadoes. Tropical cyclone. Drought. Hailstorm. Frost. Heat wave or Lu, cold waves etc. Terrestrial. Earthquakes. Volcanic eruptions. Landslides. Avalanches. Subsidence. Soil erosion. Aquatic. Floods. Tidal waves. Ocean currents. Storm surge. Tsunami. Biological. Plants and animals as colonizers, locusts etc. Insects infections e.g. fungal, bacterial and viral diseases such as bird flu, dengue, etc. What is IDNDR? Yokohama Strategy and International Decade for Natural Disaster Reduction, IDNDR, Yokohama Strategy and Plan of Action for a Safer World. All the member states of the United Nations and other states met at the World Conference on Natural Disaster Reduction in the city of Yokohama from May 23–27, 1994. It acknowledged that the impact of natural disasters in terms of human and economic losses has risen in recent years, and society, in general, has become vulnerable to natural disasters. It also accepted that these disasters affected the poor and disadvantageous groups the worst, particularly in the developing countries, which are ill-equipped to cope with them. Hence, the conference adopted the Yokohama Strategy as a guide to rest of the decade and beyond, to mitigate the losses due to these disasters. The resolution of the World Conference on Natural Disasters Reduction is as mentioned below. 1. It will note that each country has the sovereign responsibility to protect its citizens from natural disasters. 2. It will give priority attention to the developing countries, particularly the least developed, landlocked countries and smallest land-developing states. 3. It will develop and strengthen national capacities and capabilities and, where appropriate, national legislation for natural and other disaster prevention, mitigation and preparedness, including the mobilization of non-governmental organizations and participation of local communities. 4. It will promote and strengthen subregional, regional and international cooperation in activities to prevent, reduce and mitigate natural and other disasters, with particular emphasis on a. Human and institutional capacity building and strengthening. B. Technology sharing, the collection, the dissemination and utilization of information, and C. Mobilization of resources. It also declared the decade 1990-2000 as the International Decade for Natural. What is drought? Drought is a complex phenomenon as it involves elements of meteorology like precipitation, evaporation, evapotranspiration, groundwater, soil moisture, storage and surface runoff, agricultural practices, particularly the types of crops grown, socioeconomic practices and ecological conditions. Disaster Management Bill, 2005. The Disaster Management Bill, 2005, defines disaster as a catastrophe, mishap, calamity or grave occurrence affecting any area, arising from natural or man-made causes, or by accident or negligence which results in substantial loss of life or human suffering or damage to, and destruction of, environment, and is of such nature or magnitude as to be beyond the coping capacity of the community of the affected area. Glossary. Alluvial plain, a level tract of land made up of alluvium or fine rock material brought down by a river. Archipelago, a group of islands that lie in fairly close proximity. Arid, denoting any climate or region in which the rainfall is insufficient or barely sufficient to support vegetation. Backwater, a stretch of water that has become bypassed by the main flow of a stream, although still joined to it. It has a very low rate of flow. Bedrock, the solid rock lying beneath soil and weathered material. Biosphere reserve, these are multi-purpose protected areas, where every plant and animal size is to be protected in its natural habitat. Its major objectives are to conserve and maintain diversity and integrity of the natural heritage in its full form, i.e. physical environment, the flora and the fauna, 2. To promote research on ecological conservation and other aspects of environment and preservation, 3. To provide facilities for education, awareness and explaining. Bunding, the practice of constructing embankments of earth or stone for conserving water and soil to increase crop production. Calcareous, composed of or containing a high proportion of calcium carbonate. Catchment area, the area drained by a major river and its tributaries. Climate, the average weather conditions of a sizable area of the Earth's surface over a period of time, usually spread over a span of at least 30 years. Coast, the boundary between land and sea. It includes the strip of land that borders the seashore. Coastal plain, it is a flat low-lying land between the coast and higher ground inland. Conservation, the protection of natural environment and natural resources for the future. It includes the management of minerals, landscape, soil and forests to prevent their destruction and overexploitation. Coral, it is a small calcium-secreting marine polyp that occurs in colonies, mainly in warm shallow sea water. It forms the coral reefs. Depression, in meteorology, it denotes an area of relatively low atmospheric pressure, which is found mainly in temperate regions. It is also used as synonym for temperate cyclones. Estuary, the tidal mouth of a river where fresh and saline water get mixed. Fauna, the animal life of a given area or time. Fold, a bend in rock strata resulting from compression of an area of the Earth's crust. Glacier, a mass of snow and ice that moves slowly away from its place of accumulation, carving gradually a broad and steep-sided valley on its way. Gneiss, a coarse-grained metamorphic rock with a banded structure. It is formed by the large-scale application of heat and pressure associated with mountain building and volcanic activity. Gorge, a deep valley with steep and rocky side walls. Gully erosion, it is the erosion of the soil and rock by the concentration of runoff into gullies. Humus, the dead organic content of the soil. Island, a mass of land that is surrounded by water and is smaller than a continent. Jet stream, a very strong and steady westerly wind blowing just below the tropopause. Lake, a body of water that lives in a hollow in the Earth's surface and is entirely surrounded by land. Landslide, a form of mass movement in which rock and debris moves rapidly downslope under the influence of gravity as a result of failure along a shear plane. Meander, a pronounced curve or loop in the course of a river channel. Monsoon, a complete reversal of winds over a large area leading to a change of seasons. National Park. A national park is an area which is strictly reserved for the protection of the wildlife and where activities such as forestry, grazing or cultivation are not allowed. Pass, a route through a mountain range which follows the line of a col or a gap. Peninsula, a piece of land jutting out into the sea. Plain, an extensive area of flat or gently undulating land. Plateau, an extensive elevated area of relatively flat land. Playa, the low flat central area of a basin of inland drainage. Playas occur in areas of low rainfall. Protected forest, an area notified under the provisions of Indian Forest Act or the State Forest Acts having limited degree of protection. In protected forests, all activities are permitted unless prohibited. Rapids, a stretch of swift-flowing water where a river bed suddenly becomes steeper due to the presence of hard rocks. Reserved forest, an area notified under the provisions of Indian Forest Act or the State Forest Acts having full degree of protection. In reserved forests, all activities are prohibited unless permitted. Sanctuary. A sanctuary is an area, which is reserved for the conservation of animals only and operations such as harvesting of timber, collection of minor forest products are allowed so long as they do not affect the animals adversely. Soil profile. It is the vertical section of soil from the ground surface to the parent rock. Subcontinent, a big geographical unit which stands out distinctly from the rest of the continent. Terai, a belt of marshy ground and vegetation on the lower parts of the alluvial fans. Tectonic, forces originating within the earth and responsible for bringing widespread changes in the landform features. Unclassed forest, an area recorded as forest but not included in reserved or protected forest category. Ownership status of such forests varies from state to state.